Our project is uniting deep learning and citizen science for automatic land cover classification. Meet the team. Before we begin, you'll need to have a basic understanding of Globe Observer. Globe Observer is a citizen science app where volunteers can take 6 directional photos of the land cover in their communities, and afterwards, they'll classify them and upload the images to the Globe database. This is a closer look at the image classification process.
The problem is that making classifications is just too complicated. We sent out a survey to other SEAS interns, and we found that majority of them lacked in confidence in their labeling and believed their labeling to not be accurate. Oftentimes, this led to them not labeling their classifications at all. Other implications are that it's time-consuming, the labeling is inconsistent, and volunteers opt out of labeling their images entirely. All of this leads to an unreliable dataset.
Our solution was to create an automatic labeling feature through a deep learning model taught by citizen scientists. This model was meant to save time, reduce inaccuracy, and aid scientists in future research.
For our research approach, there were 2 main questions we wanted to answer. First of all, could we use volunteers to process large amounts of data in order to train a model? And then, how effective could using a deep learning model be to classify land cover? We used this 5-step process to train a model and analyze a directional photo which would determine whether sky, land, or water were present in an image.
Our data consisted of our SEAS team's land cover observations. In total, we retrieved 5,896 north, south, east, west photos over multiple states and continents. This was done through Python scripts we wrote to organize the data taken from the Globe API and download the photos, and then we downloaded the photos onto a Google Drive folder. This is a snippet of our code here. We classified the images to train using Zooniverse, a citizen science annotation tool. And then we organized our data using an algorithm that filtered out faulty images. Finally, we trained the models using binary classifications that detected whether or not the 3 land cover classes, land, sky, and water, were present in an image.
This is our labeling interface on Zooniverse, where one selects one or more of 3 main land cover categories in the image shown. The tutorial covers possibly confusing pictures such as unclear categories or temporary bodies of water. And these are the statistics from our classification.
So after we gathered our data, we trained a model to learn from this data. So we picked the model based on our desired output, which was the classification of whether a directional photo contains sky, land, or water. So we chose to use a Resonant 18 model finally for its accuracy and efficiency. We trained 3 ResNets with an 80-20% train test split that was stratified, as well as a weighted loss and sampling in hopes of counteracting our severe class imbalance. And then we assessed our 3 models on multiple performance metrics, including accuracy and AUROC. Finally, here are our results. So for our water detection model, we had a high accuracy in AUROC, but a low AUPRC because of class imbalance in the positive class. However, we still had a 0.80 TPR, true positive rate, which suggests that our model is still pretty good at identifying water, even though AUPRC was low. Next, for our sky detection model, we had high metrics all across the board because of our good balance, as well as good weighting and training. For land detection, we had similar issues to our water detection model, with very few images that had no land in them. So because of this reason, we had a pretty low AUROC, but we had a very, very high AUPRC, which favors a positive class. However, we still think this can work well in field because in reality, there aren't a ton of images taken that don't have land.
How effective were the volunteers in labeling our photos? Well, it only took them less than 5 hours to label all 5,896 of our photos, and it wasn't very difficult to set up the Zooniverse since it took less than 3 hours, including the time it took to upload the images. And were they accurate? Well, looking at the model performance, they were pretty accurate. And this is some of our future work. Next, we take the model to be able to identify all of the land cover categories in the Globe Observer app. Next, we'd like to recreate the model so it can output estimations of how much each feature composes of the area. Lastly, our final goal would be to build an app and implement it on a mobile platform like a companion app for Globe Observer. These are our references. These are our acknowledgements. And these are some extra resources that you can access by scanning this QR code.